Hi, today we'll be doing distance formula and midpoint formulas. This is from your homework page 617 to 619, number 3, 5, 7, 9, 11, 23, 25, and 53, parts A and B. So I'm going to start with number 5. And the directions say find the distance between the 2 points. Then find the midpoint of the segment joining the 2 points. So they give us 2 points. It's 0, 6, comma, and that's our first point, is 0, 6, and then 5, negative 4. They're asking us to find the distance, which means we need the distance formula, so I put it up right here for us to have, and we also need to find the midpoint, so I put the midpoint formula up. Once you know the formulas, if you can appropriately plug in your x's, then defining the distance and midpoint should not be a problem. So the first thing I'm going to do is identify my x1, my y1, and my x2 and my y2. Once I've done that, I can just go ahead and plug them into the formulas. So the distance formula says I need to take the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to start to plug this in. X2 minus x1 will be 5 minus 0 squared. And y2 would be negative 4 minus 6 squared. Well, when I simplify this, 5 minus 0 is just 5 squared, and negative 4 minus 6 is negative 10 squared. 5 squared is 25, and negative 10 squared is 100. So here I'm left with the square root of 125. Now I want to be able to simplify this as much as possible, so I'm going to try to think of a factor of 125 that's a square, perfect square. Well, 25 is a factor of 125. 25 times 5 gives me 125. And if I simplify my perfect square, I would get 5 square root of 5. So the distance between point 0, 6 and 5, negative 4 is 5 square root of 5. Now that I've done the distance, they're asking me to find the midpoint between the line segment joining the 2 points. So here is my formula. I'm going to use the same x1 and y1, same x2, y2, and just go ahead and plug it in. Well, it starts by adding my x's together, 0 plus 5, and divide it by 2. And then I add my y's together, 6 plus negative 4, and divide by 2. Well, 0 plus 5 is 5, and 5 over 2 would give me a fraction, so I'm just going to leave it as an improper, or give me a decimal or a fraction. I'm going to leave it as an improper fraction, 5 halves. 6 plus negative 4, that gives me 2, and 2 over 2 is 1. So the midpoint between 0, 6 and 5, negative 4 is 5 halves, comma, 1. Okay, number 23 says the vertices of a triangle are given. Classify the triangle as scalene, isosceles, or equilateral. Well, we need to know a couple things. First of all, we need to know what scalene, isosceles, and equilateral mean. A scalene triangle, all sides, the measurement of all sides, are not equal. In an isosceles triangle, the measurement of 2 sides are equal. Okay, so 0 sides for scalene, 2 sides for isosceles, and an equilateral has all 3 sides with equal measurement. If these are the vertices of my triangle, and I were to draw out a little triangle, we had A, B, and C, we could call those my vertices. So I could call this vertices A, vertices B, and vertices C. I need to find the distance between all points to find out if my sides are equal and how many sides are equal in order to classify it as scalene, isosceles, or equilateral. So I would need to use the distance formula, which I just plopped out to the side here. And I'm going to start by finding the distance between points A and B. So the distance between the line segment AB using the distance formula. So I'll have x2 minus x1. If I start, this is going to be my x2, that would be my 0, minus my x1, which is also 0, and square that. And then I would have my y2 minus my y1. My y2 would be 3 in this case, minus negative 3 squared. So let's simplify here. I'm going to have 0 squared plus, and 3 minus negative 3 is 6 squared. Finally, 0 squared is 0, and 6 squared is 36. So I have the square root of 36, which is 6. So my first side AB, has a length of 6. Let's go ahead and try the second side BC. So if I'm going to start with C being my x2, y2, I'm going to have 3 minus 0 squared for my x2 minus x1 squared, plus y2, which is be 0, minus 3 squared. Well, 3 minus 0 is still 3, so I should have just 3 squared, and 0 minus 3 here should be giving me a negative 3, so I should have negative 3 squared. 3 squared is 9, and negative 3 squared is also 9, which gives me the square root of 18. Well, the square root of 18, if I were to simplify that, has one perfect square factor of the square root of 9 times the square root of 2 would give me 18. So that's 3 square root of 2. So the length of BC is 3 square root of 2. So far we already know that this is not an equilateral triangle because sides AB and BC are not equal. What I want to find out is it an isosceles triangle? So I have to go ahead and figure out the length of AC. So plugging in AC, all you see is my x2, y2. So I'm going to have 3 minus 0 squared plus, and then my y2 would be 0 minus negative 3 squared. 3 minus 0 squared is 3 squared plus 0 minus negative 3 is actually also 3 squared. That gives me the square root of 9 plus 9. And I can already see I'm going in the direction. That's the square root of 18. And simplifying it the same way as we did before, I know that this is going to give me 3 square root of 2. So I can see now that the length of BC and AC are equivalent. They're both 3 square root of 2. However, the length of AB is 6. Therefore, I only have 2 equal sides, which means I have an isosceles triangle. If you have any questions, please see me or Mr. Daniels, and have a fabulous day finishing your homework.